In this video, we're going to be talking about populations, samples, descriptive statistics, and inferential statistics. So a population is the entire collection of individuals or objects about which information is desired. A census can be performed to gather information about the entire population. So when they send out the census, like the 2020 census or the 2010 census, they're trying to get information about the entire population. Suppose we wanted to know the average GPA of high school graduates in the nation this year. We could collect data from all the high schools in the nation. What term would be used to describe all high school graduates? Would we call that our population? I think so. Now, we could do it with a census, but why might we not want to use a census here? You know, there are the problems that we associate with performing a census. They take a lot of time. You get inaccurate data, missing data, and it's very costly. So it might not be the best idea in this situation. But we could take a sample. A sample is a subset of the population. It's selected for study in some prescribed manner. So what would a sample of all high school graduates across the nation look like? Think about that for a minute. Go ahead and push pause and make a list. When you're done with your list, push play and let's see. A sample of high school graduates across the nation might look like high school graduates from each state or region, from each ethnicity, gender, and things like that. So we could collect data from a sample of high schools in the nation. Well, once we have collected the data, what do we do with it? We're going to organize it. We could graph it, make some calculations with it, make some generalizations with it. To do that, we're going to use some descriptive statistics. Now, descriptive statistics is the methods of organizing and summarizing data. Descriptive statistics are used to describe the basic features of the data in a study. They provide simple summaries about the sample and the measures, and can be done numerically, graphically, or in a table. You're simply describing what is or what the data shows. If a sample contained 1,000 numbers, how could the data be organized or summarized? You could create a graph, state the range of the GPAs, calculate the average of the GPAs. Think about, what does the range tell us about the data? And what does the average tell us about the data? Now, with our sample, could we use the data from our sample to answer the question? And for this, we're going to need inferential statistics. It involves making generalizations from a sample to a population. So that means that it takes data from the sample and it makes inferences about the larger population from which the sample was taken. It's based on the sample. If the average GPA for high school graduates was 3.0, what generalizations could be made? You'd be able to say that the average national GPA for this year's high school graduates is approximately 3.0. That's what you could say. Could someone claim that the average GPA for graduates in your local school district is a 3.0? What do you think? That answer is no. Generalizations based on the results of a sample can only be made back to the population from which the sample came.